Hi, everyone. My name is Saksri Supasorn. I and my colleagues would like to present our research study entitled Portable Syringe-vial Kit for of Gas Generating Reactions for Easy Demonstration of Chemical Reaction Rate. We are from Department of Chemistry, Faculty of Science at Ubon Ratchathani University of Thailand. Rate of chemical reaction is also called chemical kinetics. It is one of the most difficult topics in chemistry for many students across the world. This topic involves many factors influencing the rate and some intangible concepts. Moreover, it requires some mathematical calculation for learning this topic. Researchers have developed some effective activity for learning chemical reaction rate. For example, iodine clock reaction observed by color change, and also blue bottle reaction. It can be observed by naked eye or using spectroscopic technique, or observe the volume of carbon dioxide gas from the reaction of acid and eggshells. There are some limitations of this activity which are performed on a time-consuming traditional scale. It is difficult to set up equipment, and it is sometimes unsuited for classes, especially at a high school level. For gas-generating reaction, the frequently used of investigate the rate because it is easy, inexpensive, and green. And the most common reaction for carbon dioxide gas generating reaction is the reaction between sodium bicarbonate and acid as follows. The volume of carbon dioxide at experimental condition and at the standard temperature pressure condition can be interconverted using the combined gas law, this one. For our methods in developing the syringe-vial kit, we first investigate the volume of CO2 from the reaction at the conventional scale by using the water displacement method as the gas measurement, and then downsizing the volume of the solution from 20 ml to 5 ml to be as a small scale, but still use the water displacement method as the gas measurement. And finally, we use the small scale reaction, but this time we use the syringe-vial kit as the gas measurement method. For the construction of the syringe-vial kit, this one is low cost and using available materials. For the main materials composed of small syringe, a glass vial and its screw cap, and 3 or 2-way connector, this one. First, we do the experiment at the conventional scale, then downsizing to be a small scale, but still using water displacement in a bullet as a gas measurement method. And finally, we use the syringe as the gas measurement method. For the experimental procedure, here, this is the illustration of preparation of sample, and this one, how to load a sample container into the vial. And for this one, connecting all parts together and then checking the reaction to be mixed well. And the last one, measuring volume change in the syringe with time. For the demonstration video of how to proceed this experiment is as follows. let's see the video. Pour the acid solution into the vial, followed by loading the solid reactant container into the vial. Make sure that there is no solid spill into the solution. Then close the lid. When you are ready, check the reaction to be mixed and then observe the change of volume with time. The volume of carbon dioxide and rate of reaction from our experiment is shown in the table. You can see that there are three sub-reactions: reaction A, B, C for the conventional and the small scale method. Their percent yield were in similar order. You can see here that for the conventional, reaction A is the most percent yield. Oh no, reaction, the order of the percent yield of the reaction is C followed by A and followed by B. And for the rate of reaction, we study the rate at 20 seconds instead of the rate of the initial rate for easy calculation. You can see that the order of the rate of reaction is in similar order for both the conventional scale and the small scale using the syringe-vial kit method. You can see that the reaction C occur fastest, followed by reaction B, and for the last one, reaction A. Our conclusion is the syringe-vial kit method can yield reproducible data as the conventional water displacement in a bullet method. It can be used as a classroom activity, which is what's suitable for the investigation and demonstration of the concept of reaction rate. This method minimizes some limitation, including repeatable, low cost, safe to perform, and easy to set up and operate. This one can be done within 5 minutes. This method provides students a chance for individual hands-on activity. And finally, we would like to thank for your kind attention. And this study is under the project code ISA 5980021, which is co-funded by Thailand Research Fund and Ubon Ratchathani University. Thank you and bye-bye.